how to make our planet great again. That is particularly in the political debate we have right now across the ocean an interesting wording, isn't it? So I'm really looking forward to hear that. And I would ask you to take over from me. I will stop my sharing and I wish you all the best for your session.
Thank you very much, Mr. Brandenburg. I try to start my presentation and welcome you all for the second part of this DAAD session. My name is Anke Stahl and I'm heading the section, the Division for Internationalization and Research at the DAAD and University Networks. And we are going to address another grand challenge in the second part of the session, climate change. And this time from the perspective of two research projects, which are part of the BMBF-funded research program, Make Our Planet Great Again. And amongst others, we want to show how challenging it can be for research, especially fundamental research, to pave the way to a societal impact in the long run. So I have to move my slide. How can I do this? Here. Let's look back to the year 2017. I guess these two guys are well known to everyone because they played a very significant role that our funding scheme we are going to talk about today was born in June 2017. Trump by leaving the Paris Climate Agreement to make America great again, and Macron by calling on researchers and other groups to mobilize and join France in the fight against global warming, and by announcing a climate research funding scheme, Make Our Planet Great Again. This call was followed by Germany, illustrating thereby France's and Germany's fight or desire to be at the forefront of the fight against climate change. And in the end, since 2018, altogether 55 international research projects started in both countries, 13 from these in Germany. The program's overall objective is that it shall contribute to achieve not less than the goals of the Paris Climate Agreement. That means from the international research collaboration, which takes place in 3 different fields in climate change, Earth system science and energy transition, a societal impact is expected. This approach finds its expression in this joint statement you see on the slide, this joint statement of the 55 international laureates of the program during their first conference in Paris last year. With their research projects, they want to draw attention to the global climate crisis and to exchange ideas among each other. The aspiration is very high when they wish to effectuate a rethinking in politics, economy, and society. However, to achieve these objectives requires more than research work. The path from aspects of fundamental research to gains in knowledge with an impact for society remains still unclear. Now I have the pleasure to introduce 2 international researchers from our 13 projects in Germany who will illustrate these challenges from the perspective of their research projects. I would like to welcome Dr. Henry Wu from the Lightness Center for Tropical Marine Research at the University of Bremen, and he will talk about his project OASIS. And I welcome Dr. Matthias Tesche from the University of Leipzig, and he will talk about his project Pacific. By the way, both researchers, they address 2 of the base elements of life, water and air. Henry, you will start and the floor is yours. And you shall let me know when I should move the slides. I think I'm the only one who can move it.
Okay. Great. Hi, everyone. My name is Henry Wu. So my Make Our Planet Great Again research initiative project is Witnesses to the Climate Emergency, Ocean Acidification Crisis, and Global Warming Observations from Tropical Corals. The acronym is OASIS. And so the background is basically that we know atmospheric CO2 has been increasing at an alarming rate since the Industrial Revolution, and the absorption of the atmospheric CO2 is acidifying our oceans and impacting coral reef and coastal environments. And so, however, there's really not a full scope to the understanding of these chemical changes taking place in the oceans. And because there hasn't really been any monitoring and documentation over, well, since recent times from satellite observations and manned observations. And so my project aims to reconstruct the state of our changing ocean, these variability, trends, and changes, and assess really the impact and consequences of atmospheric CO2 uptake in our tropical oceans before and since the Industrial Revolution. And here I have a little photo of corals, baby corals, where you can see on the left side, panel A and B, at 27 degrees Celsius and 390 ppm CO2 level, which was about 2015 levels, how happy the corals would be versus when they are warmer in the 2 degrees Celsius warming scenario on the right-hand side, and how under ocean acidification conditions, the lower panels, E, F, G, and H, how the corals become less happy compared to their cousins up top. Next slide, please. Yeah, so my project really wants to understand CO2 uptake in ocean acidification, and we use these coral cores to reconstruct this climate. And the historical climate records can really be used as a modern benchmark for model simulations. And what we really want to do is have our results enhance the knowledge of coastal communities and shellfish fishermen, farmers, and all the communities that depend on the coral reef environments and local resources for their livelihood. And I think this is one of the aspects of this IHES conference, is the benefit of the wider community from that we're trying to achieve through this project. Next slide, please. Yeah, so besides publications in international peer-reviewed journals and also having international collaboration partners, we also try to have presentations at conferences such as this, but more specific to our field, say in the European Geosciences Union annual conferences or the International Coral Reef Symposium. And we've initiated in the past couple of years these MOPGA specific sessions trying to bring together the French and the German researchers. And such conferences are attended by over 20,000 earth and environmental scientists in the field related to climate change. So it is our attempt to bring all the projects together. And my institute, the Lightness Center for Tropical Marine Research, also conducts, well, we only conduct research in the tropics. So we're in a great position to connect my research project to many tropical countries. And so it's not just that we're coming out to the tropical countries, landing to take their samples and bringing it home, but rather we want to have local partners providing opportunities to bring the knowledge back to them and build additional capacity for research, for future research in their region. My institute also publishes these local, these small policy briefs from our Office of Knowledge Exchange and some of these talking points newsletters where we try to communicate and engage with the local communities. And we really work hand in hand, natural and social scientists, trying to bring all this accumulated knowledge back to the local stakeholders in tropical countries. And recently, I also conducted interviews with the Spektrum der Wissenschaft in October issue, kind of explaining what our project is about and a little explanation on this current ocean acidification crisis. And yeah, that's all I have for now. We can have a question and answer session later on. Thank you.
Thank you too, Henry. And I would hand over to Matthias to introduce his project specific.
Thank you, Anke. So just like Henry's project, mine is, well, actually a proper research project. It also has a quite convoluted title, and we can shortly call it Pacific. And the aim of the project is to look at the effect of aerosol particles on clouds, and in particularly how those change the cloud properties. So that's, it seems like a very simple issue, but for several decades now, we know that those effects exist, but we still, for now, didn't really manage to get a grasp on what the actual impact is. So we know that clouds cover large parts of the Earth, and we also know that those clouds lead to a much larger reflectance of the Earth compared to if there were no clouds. So that means that about half of the solar radiation that is reflected back to space is reflected by clouds. And if we now change the properties of those clouds due to changes in aerosol concentrations, then this can have a huge effect on the Earth's radiative budget. But we don't know really what happens, even though we have been looking at this for a long time. Particularly when you look at the IPCC reports, you will find that while there is hypotheses of what is happening, we don't know what is happening exactly or the magnitude of how those mechanisms work. And in particular, we don't know anything about the uncertainty range. So for 20 years, we have not managed to narrow down that range. But what we know that is happening is that, you can see this on those pictures on the right, if you have a closed cloud deck, like you can see in these three orange shaded panels, those orange colors represent clouds, low clouds in particular, and they consist of a certain amount of water vapor that can condense and form cloud droplets. If you now add a source of aerosol particles below those clouds, like you can see in these examples, so there's those really bright spots in the upper picture. One is Moscow, the other one to the left is St. Petersburg. And of course, those cities emit lots of aerosols from combustion, for instance. In the lower plot, you can see aerosol sources from biomass burning, in particular from forest fires. And what is happening is that you have this extra source of aerosol particles. This leads to an increase in particle concentration, and the water vapor that condensed on the particles that were available before now suddenly has much more particles to condense on. So the particles will be smaller and the clouds appear brighter. This is exactly what you see on this right side picture. This is also a feature that you can find, for instance, for ship tracks. So when you have a closed deck of marine stratocumulus and a ship passes underneath and emits exhaust aerosols into this cloud deck. So we know this is happening. We also know that a couple of follow-up effects occur, but we have had little grasp on how to study those. So often this is done in form of models or with satellite observations. But Anke, can you please go to the next slide? If you use these satellite observations, quite often you would have a polar orbiting satellite, which is a satellite that circles around the Earth at around 400 to 700 kilometers height, and the Earth revolves underneath. So you can never really observe the same cloud multiple times. So the approach that we want to follow in this project, and which strangely hasn't been done before, is to use a different kind of satellite observation from so-called geostationary orbit. So this is where your regular weather satellites would be located that provide you the nice weather pictures for the news. So we have this full disk image that you can see on the top right corner. But we can take a certain part of this region and identify clouds and then track those in time, because those satellite sensors, they are always at the same position and they manage to observe the same area with a temporal resolution of up to 15 minutes or even less. And that's what we do. So we identify those clouds, and you can see those as blobs of blue in this lower left picture. And then when we follow this cloud over several images that are taken by the sensor, then we see how those clouds move in this cloud field, and that's what those lines are. And what we want to do is we want to see how those cloud parameters that change with time evolve if they are in a different aerosol environment. And that is more or less pretty much basic research. And Anke, can you please go to the next slide? And the expected long-term outcome would be that we manage to provide a parameterization for climate modelers that enables a better description of these aerosol cloud interaction effects. In particular, our approach is measurement-based, which is usually not the case, and it's only measurements that can provide a proper benchmark. So now in terms of international visibility and challenges, I thought about it for a bit, and then I realized that my field is by default international. So when I looked at it in a bit more detail, then I found out that the World Meteorological Organization actually dates back to the International Meteorological Organization, which was already founded in the 19th century. So it was one of the first organization where global participants combined their efforts to provide something better. And for the atmosphere, you need to have observations from everywhere. We also use satellite observations. So these are from data providers that can be in the US or in France or in Japan or anywhere really. And also the development teams are quite international. Also, the exchange of results is always international by default. All journals are by default in English, are peer-reviewed by international colleagues, and those research articles are also our main pathway of dissemination of the results. And that's basically because my work in particular is so far down, or so at the bottom of the scientific food chain, that it's so basic that we first need to find somebody who's interested in it through a scientific publications that can then implement it in their model and then provide some impact once they run the climate model and provide a better estimate of the effect of aerosol cloud interactions for future climate, but also for past climate, which we need to understand as well. Besides this scientific dissemination pathway, some things I really like to do is to give presentations to people that have no background in this whatsoever. So that's something I've done this year for a company called Ravensburger, which are producing board games. And they were really interested in the topic. They wanted to make the company greener, but they really lacked a motivation. And having somebody talk about the climate change issue and the challenges we all need to face and the ways we can contribute as individuals really made a big impact for them to justify the shift to a greener company. And I think that's my 8 minutes.
Thank you very much, both of you, and for sticking to the time frame. We had an exercise, or we tried to prepare this very strictly to stick to the time frame. Thank you very much also for giving us these insights into specific research projects and made it understandable for all of us. Now we have the floor. We have a couple of minutes time for questions and discussions, and but I found out I had to stop my my screen, sharing my screen, otherwise I cannot see the questions and answers. And before I give the floor to some questions and answers, I would like to draw your attention that if you're interested in further discussion with our experts, there will be a DAAD chat room right after the session. And the link you find here, and we will be available right after the session from 11:15 to 12:45. And there will be also tomorrow the opportunity for joining our DAAD chat room with the experts between 11:15 and 12:15. This is just for your information. And now I would like to stop my sharing the screen so that I can see also the questions. There is a question from the TU Dresden Strategy and Internationalization Department I would like to read. Thank you so much for your slides, but even more for your engagement in your field and sharing with the society. I'm sure we all agree that increasing the understanding of the wider public of these fundamental topics is really important, and it's wonderful that you are doing this. However, thinking of the limited resource time, how do you distribute your time between your research and scientific publications in high-ranking journals, important conferences, which is important for your career on the one hand, and work for society on the other hand? Do we need more support or systematic appreciation for this second part of our scientists' work? I think this addresses a very crucial point as in your life as a researcher and to be a communicator. And I would like to address this. Maybe Henry, you would start to answer. How do you manage to communicate to a wider public and do your research?
Yeah, this is a great question. We are actually it's really difficult. And because a lot of these performance indicators for, say, tenure track positions do not consider a lot of these international, say, community service, or besides how many papers you published and how much money you brought into the institute. And really there should be a systematic change in a lot of these international institutes. And my institute recently has gone through this Lightness evaluation. And one of these topics was, how do we consider production in these policy briefs and other kind of white papers that we produce, which doesn't really have the academic impact, say impact factor in journals, but yeah, this is we don't have an answer at the moment, and I really do feel that there is a need for some sort of systematic, appreciation, as you said.
This was opinion from a more applied research from Henry's perspective, and maybe Matthias, you would like to add something on this?
Yeah, of course, I can add something. Well, it really is the question that we need to answer is what are scientists supposed to do? So are they supposed to do science, or are they supposed to do secretary work? Are they supposed to do outreach work? Are they supposed to write press releases? Because in the end, that's exactly what we do. So we have to supervise students. We have to get more funding so that we can continue our work. And in the end, there's almost no time left to do the actual research. And that's quite a pity, because then you have to publish as well so that people see that you do something, and you have to do all this community work. So you have to be engaged in your scientific societies. You have to review papers. Me personally, I'm also editor for a journal, and that takes a lot of time. So of course you get lots of good feedback, and you are really on top of the topic. But in the end, there's only very little time left to do your own contribution to this. And that's why these DAAD projects were so great, because they gave us the possibility to get our own team and to get some students or postdocs that could work on our ideas so that we actually get something done. And when you look at more established researchers, you will find that they hardly ever publish any first author papers, because they simply don't have the time for that any longer. So all they do is just distribute ideas, advise junior scientists what to do and how to improve their work, and that's it. And then more and more part of their time has to be reserved for administrative duty.
So at the end of the day, if we take IHES seriously, I think there should be also a cultural change and appreciation of research work. I mean, that not only high scientific publications or in high-ranking journals should be appreciated, but also the engagement for society should be a kind of value.
Mhm. I guess you could say that even though we studied for a long time and we get a PhD and everything, we are really not prepared for what's going to happen because, first of all, the landscape shifts continuously, and then you really don't know how well you will be supported in your institution where you work, how good your team members will be if you are fortunate enough to be able to recruit somebody. So it's quite difficult, and there's no one-size-fits-all solution on how to become a successful researcher.
That's right. I have another question for you both. Would like to read, how can scientific community effectively counter the misinformation campaign from global warming deniers, as well as conspiracy theories circulating around? Comes from young David Vargas. Any idea how to fight?
Henry, do you want to go first?
Sure. It's been going on. So at least as an American, U.S. American here, this problem has been going on since the early 2000s, mid 2000s, since the second Bush administration. So that this topic of climate has become so politicized that a lot of climate scientists, we have been attacked. They have really gone into people's emails and have said, oh, you made adjustments to climate records, and that is the hiding of the warming or the cooling or whatever it is that they find. We have a lot of ways to push back on this narrative. We use just the blogs and web pages that scientists do, and now with Twitter, and it's getting a lot more intense. And this is the only sort of way that we can bring in our scientific facts to this fight, I guess. But a lot of the times, these global warming deniers are just not listening to facts. And I actually don't know how, besides bringing out the facts, and we publish in blogs and Twitter, the newest research, I don't know how else to fight this.
I guess the best approach probably is to make sure that younger generations will understand the issue. I mean, those conspiracy ideologists and climate change deniers, they are, well, my personal opinion is that they are basically lost for the discussion, because whatever you tell them, if it does not agree with their worldview, then by default it means that something has to be right, and they are still the enlightened people. So they're basically lost. That's my sincere opinion. You would need to make a big effort, probably on a personal level, to convince somebody who is an active climate denier that whatever they say is wrong. Or you need to really find out what the reasons are for their opinion. So is it because they are following the wrong kind of news outlets or the wrong kind of sources of information? Or is it because they are just not really interested in the matter and just basically say what somebody told them without really checking for themselves if it makes sense or not. So if somebody is not engaged in the topic to begin with and then hears something, then they might just accept this for the truth. And those are the people that we can still reach. But those hardcore climate deniers, I don't think there's any way to get them, because most of them also follow their personal agenda, which might bring them profit or, I don't know, status or whatever. So there's really no way of getting to those people. That's my sincere opinion.
I am very, very impressed by the incredible timekeeping you have in your session. That is marvelous. And I also have to say, I am very, very impressed by the projects you do. And quite honestly, I think that, for example, that both projects you present here would be something that would be very, very interesting to the internationalization community as such, because you have a way of expressing scientific results that make them interesting and understandable, which I think it's, especially in the climate change debate, is of course a huge issue. So I thank you very much. I'm sorry that I always have to interfere like this, but that's my role and I have to love it. So what I would want to do is, first of all, again, thank you very much for your participation and for the fantastic presentations you've given us.